Myself and Joe. I'm a third year student, he's a fourth year student. So the way it's going to work is we're going to go through these things, Linux, then we're going to have a quick break, network, and then a Q&A. We're students, we're approachable, so ask us anything that you want to, but please wait up until we finish the big Linux block, then ask us anything you want to know about Linux. Same thing with networks. The final Q&A, you can ask anything about the workshop that we're going to have tonight, or anything relevant to CDX. We're open to give you all the possible hints that you want. Right, so let's kick off with Linux. In case you don't know what Linux is, it's something that you're probably going to end up working with for the rest of your career. Most of the phones run on a Linux Unix-based operating system, which is Android. 90% of the servers in the world run on Linux. Facebook has some Linux servers, and that very funny penguin is Tux, which is the mascot of Linux. So the first thing that you need to prepare yourself with when you're dealing with Linux is the terminal. The terminal is one of the main differences between probably what you're used to, which is Windows, and an operating system like Ubuntu. So there is this difference between the so-called GUI operating system and the CLI operating systems. So a GUI, graphical user interface, are those like very funny animations and pictures and windows that you can open, close, drag, and do all the operation that you're used to, which is good, but is not very powerful. We are computing scientists, we want to do powerful things. So we need to speak directly to the computer without having to go through all the windows. Hence, we use something called the terminal, which is this thing over here. It's not as intimidating as it might be. I don't know how to, right, make it a bit bigger so you guys can read. So this is the terminal. This is the interface that allows you to communicate directly with your computer. And to do so, you need to speak computer. And the way to do this is through commands. Commands are like they are programs that are already installed on your computers and you can speak to them. So as any other programs that you probably have used, so as Python or HTML or any other programming language that you've used so far, it has a syntax. And so, for example, if you want to install stuff on an operating system, the first command that you need to do is apt-get. Now, after calling the name of the program, which in this case is apt-get, you need to specify some options. So, for example, if you want to install something, I can't write, you would say install, and then the name of the package that you want to install. So the name of the package that you want to install in that case will be your option, your argument, and the program will go on his list of repositories and look for your program and install everything for you. Another way of having options, for example, is using the so-called dashes. So -f is the flag that in this case, and this is a useful command when you're trying to install stuff really quickly on your computer, if it's missing any dependency. So if the package that you're trying to install is missing any other package it's depending on, issuing this command will automatically install everything that it's missing. Because I keep my computer up to date, it's just telling me there's 0 to upgrade, 0 new install, you're good to go basically. It's good whenever you are using a new operating system to quickly do apt-get update and apt-get update, and I'm going through the commands on the very left hand side of the slide. Apt-get update, all it does is goes online on the list of the programs that you're supposed to have on your computer and creates a big list of everything that you're supposed to be running to be up to date. Then if you issue sudo apt-get dest upgrade or just upgrade, is going to install all these files that it has in the list. If you want to remove something, you have two options. Either go with remove or with purge. So it's a bit more complicated than it is on Windows, which is just like you go on a list of programs, so click on remove, everything is done for you. Because this is more powerful, the way to do it is apt-get remove and then the name of the package. And then the next time that you issue the command sudo apt-get auto remove is going to go on and remove everything that was on the list of the stuff that had to be removed. Again, I don't want to remove anything on my computer because I don't want to kill it, so there is nothing to be removed. If you want to remove all the dependencies, all the files that are getting installed, all the log files and everything that have been left over by the program that you used, then you use purge instead of remove. The only difference is that purge literally removes everything relevant to that specific command. Another way of installing stuff is by downloading it from a website, like you probably have done multiple times using your Windows. You just go to the website, click on download, and you just double click on the exe and Bob's your uncle. You're done, you're all set up. Well, with Linux, there is an option to do something similar. So you can go to a website, download a package in the .deb extension, and then you just issue dpkg-i and then the name of the package, and you're good to go. So, output operations. Another really important and crucial thing that you should know how to master really well, especially in Linux and especially for CDX, is what you can do with the output of a program. The terminal is great because you can literally take the output of one of the programs and use it as the input of a second program. You can create a long chain and you can get some information, then you can filter it, then you can get just what you want to be inputted in, I don't know, for example, your IP table and ban certain IPs. It's really, really useful. So to do that, we need to be familiar with the first three things that I wrote over there. So piping, writing, and appending. So piping, which is this symbol, literally gets the output of the first program and pipes it into the second one. So let's have a little small example. For example, if I issue the command arp scan, just to remain in the theme of CDX-L, well, of course, I need to be root. Well, all this is happening. I'm not getting in the matrix. All these numbers are going to make sense after Joe is going to give his talk. You're going to understand what is going on there. But all I'm doing is scanning the current network, and I'm trying to get all the devices and get their MAC address and their IP address on the network that we are all connected to. So this is a hell of a lot of data. And if you see on this right-hand side, you have loads of unknown, and it doesn't really give me much information, right? So how can I just filter it down to something I can actually read and work with? Well, I can pipe it into another program, which is grep. Grep is a great utility to filter specific parts of a file, or in this case, of the output of a program. So if I issue the exact same command, and then use the pipe, and issue grep, this is just telling the program, issue the first command, whatever is the output, put it inside grep. At this point, I'm going to use an option of grep. Remember, options is specific stuff that I can tell the program to act in a specific way. So in this case, it's -v, which is whatever does not look like it's unknown. So all it does is it's basically applying a filter, and it's saying return me all the values that are not unknown. And if I haven't made any mistake, yeah, I can't write. Right. So now it's doing exactly the same thing, but it's filtering out all the unknown ARP addresses. And it's giving me the information in a readable way. But this is not good enough. We can do better. So, for example, let's just say that I want to save this for a future time and remember what happened at that specific time. I want to create a log file. Log files are really useful, and you should use them. And basically, it's just logging everything that happens. It's great for debugging, and specifically for CDX, it's great for monitoring. If you log specific things that happens in your machine, you know who accessed them, who did something, who modified something, what was the last access. It's all really useful information. So for example, I'm taking the exact same command that we have before, and then at this point I am writing, so I'm using the walker, into scan.log. And this command will go on and silently execute the argscan, filter it out, and save it to scan.log. Now it's going to take a little while, so we're going to leave it on the side, and we're going to wait until it's done working. I'm going to open up another terminal. You can stay here. And we're going to do a bit of basic file operations. So, of course, we're computing scientists, so what we want to do is write programs, write specific files and stuff. So, if you're accessing a server and you don't have the graphical user interface, because yes, this is Linux, this is a version of Ubuntu, and I'm using Windows, you could literally just open up a text editor and use it as any other GUI operating system. But that is not what we want to do. If you're accessing a server and you don't have a graphical user interface, you need to be able to write text files even if you don't have a window. So some of our favorite text editors are Vim and Nano. Vim builds on something really painful that was used in the past, which is VI, which is really, really hard to use. So we're not going to go in there. But Vim is a text editor. So Vim is VI improved. Thank God they improved on that one. And it allows you to create files as you would do in your notepad. So I'm going to quit for a second. And I'm going to create a new file called Vim, I don't know, example.txt. This way it's just telling me, right, okay, I just created a new file called example.txt. Now just like tell me what to write inside. So for example, if it was like an HTML5, an HTML file, I could just like go on and write the HTML code. But if you try to write anything right now, I'm pressing buttons and nothing is happening. No file under cursor, like what is going on? Well, Vim is a console program, so I need to tell him first of all, right, from now on, whatever I'm writing, you need to insert it in the file. So I need to press I, and now I'm in insert mode. At this point, I can just like go on and write my HTML code. Hello world. Of course, because it wouldn't be a computing science talk without a hello world. Okay, so I have my beautiful HTML page. Now I want to tell them to just like save whatever I've done and close the program because I'm done. This is the best program I can think of right now. So what I'm going to do is I'm going to press ESC, and at this point when I press exit, it's just waiting for me to tell him what to do with this file. And the way Vim works is you need to put a column, and you see that what I'm typing appears in the lower left corner. I just like write W for write and Q for quit. Press enter, and well, it looks like nothing happened, but it actually created a file and with whatever I wrote inside. So how can we view this file? Well, another command that is really useful is ls. What ls does, it lists what is inside the directory I am currently in. It lists all the files, directories, and whatever that is, it's under my directory. And if you look, we have the scan.log, that is the output of the programs that is running in the background, and we have somewhere the HTML file that we just created. No, example.txt, which was the file that we just created. So to navigate through different folders, you use cd, which is change directory. The syntax for cd is cd followed by either the name of another directory, or you can use dot and dot dot. Now, one thing at a time. So for example, you see that I have a directory called Linux Raspin here. So if I type cd Linux Raspin, hit enter, you see that right now it's just telling me, right, you are inside Linux Raspin. So if I do ls to see what's inside Linux Raspin, it's going to tell me, okay, inside Linux Raspin you have another directory called debian and everything else. So we successfully moved in another directory. But we just noticed that we don't really care about Linux Raspin. So we want to go back to where we were. The way to go back, to go one directory up, is to write cd ... and this way we're just back from where we started. So use cd to move into directories, use ls to see what's inside the directory, and at this point, if I want to edit again my beautiful HTML code, I just need to write vim example.txt, and there is my beautiful HTML code. Right. But this is not all we can do with files, right? We also need to move them, we need to remove them, we need to rename them. How do you do that on an operating system like this? So, next command is how to move a file, which is also a trick on how to rename a file. Because oddly enough, when the terminal and bash was built, people were like, well, we can also people can use just move to just rename files. So I'm going to show you how. If you write move and then, for example, example.txt, and I want to move example.txt inside of videos, no, wrong command. I have no idea where I put it. Right, okay, yeah. 1 second. Okay, so if I want to move example.txt inside of the folder videos, I just write move, the name of the file I want to move, and where I want to move it to. So when I hit enter, if I show ls, you see that there is no example.txt, but if I go inside of videos, I'm trying to use the autocomplete function. Here it is, example.txt. We successfully moved it. So how can you actually type so fast? You see that sometimes they just type the first 2-3 letters of something and then it magically autocompletes. Well, great things with the terminal, if you start writing the name of a file or the name of a directory and then you hit tab, it will autocomplete the rest of the word for you if it makes sense. It's also a good way of knowing if you're doing something stupid or not. So let's say that I don't really like the name example.txt because it's an HTML file, so it doesn't really make a sense that it's a TXT file. So what I'm going to do is I'm going to issue the same command that I had before. So move example.txt, and you're like, wait, but you're not moving, you want to rename it. But if I move example.txt to another file called example.html in the same directory, what Linux is actually going to do is copy bit by bit example.txt into a new file called example.html. So if I hit enter, look at the files, there you go, I just renamed it from example.txt to example.html. Right, how do you remove stuff? Now, big disclaimer here, be really careful with this command. I personally had a considerable amount of nightmare, especially before deadlines when I accidentally removed the whole of my R disk. So be really careful of what you do with this one. So the command to remove a file is rm. Rm, all it does is it removes whatever I'm telling him to remove. So if I don't like example.html, because frankly it's not that good of a website, I just write rm example.html, hit enter, and it's not there anymore. It's gone for good, thankfully. But maybe you don't want to only remove a specific file, you want to remove a whole directory. And if you try to remove a directory just using rm, you'll notice that the system complains because it's like, right, this is not a file, you know that this is a directory. So, for example, I'm going to create a new directory just for the sake of this presentation, and I'm issuing the command make dir. Yeah, just noticed. Thank you. And I'm just going to call it example directory. And there you go. We have our example directory up there. Now I want to remove it because this is the whole point of this command. So I'm issuing rm-rf. So, well, to be honest, I could also get rid of the f, but it's good to be thorough with this one. So rm is the command that we were speaking about before, and the r, the -r means is recursive. So when you issue that command on a directory which is full of files, it will recursively go through the directory and remove all the files inside that directory. The f means force, so it's just like, so it doesn't throw you any error. So when you append that f, make sure that you know what you're deleting, for the love of God and for the love of your own sanity. So now I can just go on and remove the example directory, ls, and the example directory is gone. Good. So at this point, I am pretty sure that we are done with the command that we instantiated before. It's done. So what we've done here is we created the scan.log file containing the ARP scan of this network, removing all the unknown MAC addresses. Now, what happens if I want to see it? Well, you could instantiate them and just watch what's inside that, but that's not fun because I already told you how to use them. So a really old school way of viewing a file in Linux is using cat. Cat literally prints out to the screen what's inside a file. So if I choose cat scan.log, it just prints out the content of scan.log inside of my shell, and I can scroll up and down, but that's not really cool. You can't edit, you can't modify it, you can't do many of the options. So another text editor that we can use is Nano, which is a bit more friendly than Vim. So this is Nano. This is another alternative to create and modify files. And I'm not going to say which one is the perfect one, because there's a huge debate between computing science if it's better to go with Vim or with Nano. I don't want to go there, so I'll let you judge. It's less complicated than Vim because you can directly modify and insert stuff as you open up, and it tells you exactly what to do if you want to, for example, exit, if you want to write out, if you want to know where it is. So there is a search function. So it's easier to learn how to Nano than how to Vim. But whatever floats your boat, as long as you know how to open up files. Another thing that I wanted to show you is less. So it's a pretty long output, and if I want to use cat because I'm an old school hacker and I want to just look at my file in the terminal, what I can do is I can pipe the output of cat in less. And what less does, it just shows me the same file a little bit at a time. So whenever I press enter, it goes down up until the file is over, and it just tells me end. I press Q and I'm out. So again, like we've seen before, we can literally take the output of a file and pipe it into another program. Okay, so we know how to pipe, we know how to write to a file, but what if I want to append something else to this scan log? Well, what I can do is issue a new command, for example, netstat. Netstat is going to print out the status of my network card, so it's telling me ooh, okay, good. So sudo apt. Sorry? Oh yeah. Netstat. It's the Scottish version of netstat. Right, so it's telling me who I'm connected with, on what port, but I don't want to spoil the rest of this lecture, so I'm not going to go in deep into this part. So if we have the log file right over here, scan.log, but I don't want to delete this because I need that data that was in there. I just want to append stuff to this file. So what I'm going to do is do netstat, and then double walker and scan.log. So what I'm going to do is get the output of scan.log of netstat and append it at the end of scan.log. So if I do again cat scan.log, and so this is the file that we had before, but we appended all this thing. It was very long at the end of the file. So now I have a big log file that both contains my ARP scan and my netstat. So this is how you can create your log file. Doing piping and writing and reading from files is really, really important, especially in a Linux box, especially for what you're going to do. And just like play around a bit, create some files, try and experiment. There are loads of good guides online that tell you more in details how other fancy stuff that you can do with this. Logical operators, they work in the Linux terminal as they do in Python. So you have and, or, equal to, or different than. They work exactly as they work in Python or in any other programming language. So you can do a logical operation between things even in here. Now, can we execute more than one command one after the other? Yes, we can. As a matter of fact, we have two ways of doing it. So when you write a list of commands, you can either separate them with a semicolon or separate them with an ampersand. So hopefully you won't notice the difference between doing either the semicolon or the ampersand, because what the program is going to do is execute the first command and then execute the second one. The difference is that with the semicolon, I'm executing the second program whenever the first one finishes. But I don't care if that program finished because it crashed or if it returned an error. I'm just going to execute the second command as soon as the first one is done. With the ampersand, I'm executing the second command if and only if the first command is succeeded. So this is a very, very important difference if you're trying to install certain packages in a specific order and you don't want to finish the installation if one of the packages in the middle of the line just crashed. It's really useful, know the difference, and what I could tell you is like normally just like try to go with the ampersand, so at least it will like stop midway and just tell you, right, there was like something that wasn't quite right in the middle of it, and you can go back and debug and not wait up until the end and maybe not notice. So I think that we are done with the basic commands. I just want to quickly cover man. Man is the manual. So if you don't remember the syntax of a command, you don't remember what it does, what you have to tell him, you just like write man and then the name of a command that we, for example, wget. And it will tell you the name of the command is wget. This is how wget, then you need to specify an option, and after the option you need to specify the URL. You scroll down and it just like tells you a bit about the story, a bit about the options, gives you examples. So it's like your small Stack Overflow inside your terminal. Use it, is your friend. Sometimes, especially if you're really, really tired, you're just like doing very stupid mistakes, you don't even notice. Just go man that command and you will easily find out the answer to your questions. wget, to quickly cover it up, it just like downloads the web content of a page, and I think I covered all the other commands. Okay, so a quick diversion on get. So in case you don't know what get is, it's gonna haunt you for the rest of your career, but it's a good thing. So get is a system that helps you keep track of your code, share your code, and also save your work in many occasions. So the way it works is like you have a code, you upload this code to a Git repository, and you create a master branch. So the master branch contains your code, your main code, the working version of the code, the one that you don't want to lose. So a team member just come along and is like, right, I want to add a button, or I want to add this function. So what it does, it clones the code from the main repository, creates another branch, and works on the code. When it's done, it's going to push it back to the main branch, So the idea is that the master branch is always the one that functions, that is working, that passes all the tests, while the other branches are the development ones that you can experiment on. Now, I'm not going to go in depth with Git right now because it's not really relevant to CDX. The reason why I put it inside the slides is because there is another command to install some programs, which is git clone. Especially for security, there are loads and loads of libraries that you can find online because Googling is an option. And you will find that 90% of them are on GitHub, and they're open source, which is great. So the way to get them on your computer is to just like issue git clone, the name of a Git repository that will install the Git repository on your computer, and at that point you can follow the instruction on that Git repository and install your program. Right, I think. User types. Okay, so you've seen that sometimes tonight I had to use a really weird command that I never mentioned, which was sudo. I'm going to tell you why I was using that specific command instead of just issuing a random command and just like hitting enter. So think about it this way. When you're young and you're at home with your parents, they would probably stop you before you put your hand in the blender, because it's something that is stupid, is going to harm you, and it's something that they don't want you to do. So they're making sure that you're safe, that you know what you're doing before you do it. Same thing with Linux. Linux is like your parents, put it that way in this sense. So when you're young, Linux is not going to allow you to do some things that may harm you. So possibly don't completely format your hard disk, because that definitely happened. The battery is going down. It's all right. Oh, there's one here. Whoa. Okay. Right. Sorry about that. Turns out that computers actually need electricity to work. Didn't get the memo. So there are different user types inside of Linux with different permissions. So Linux will forbid you from doing certain things that may harm your computer if you're not responsible enough. So if we start from the bottom, the lowest level of trust that the Linux operating system puts in a user is the guest. You can also like disable the guest, and in some Linux version, guest user cannot even save files. They get removed as soon as you switch the account off. A good thing to do is sometimes to just like disable the guest user on your operating system, because honestly you're not going to need it. Then you have the normal type of user. The normal type of user can still open the file, read the files, do almost everything that we did tonight. So as long as you're like creating a new file, removing it, there's no problem, and you have your freedom. But a user, like when you go to university, can be added in a sudoer table. The sudoer table is literally a table, a file, containing a list of users that are trusted to do some operations, even though they're not properly adults. So if your user is inside a sudoer table, if you append the word sudo to your command, you're telling your computer, right, I know what I am doing, trust me, execute this command anyways, override your security and trust issues. To make sure that that you know what you're doing, Linux is still going to ask for your password, just in case. The highest degree of trust is the root user. Be careful if some of you install, for example, Kali Linux. Kali Linux by default boots you into Kali Linux in the operating system with root permissions, which is good because you never have to use sudo ever again and you don't forget halfway through a presentation. But is bad because he's not going to ask you twice before he executes whatever you tell him to do. He's just going to believe you blindly, you're his god, and he's just going to execute whatever you're saying. I put admin in brackets because for some operating system, there's still a way in between the sudoer, a sudoer user, and a root user, but in 90% of the operating system that you'll probably come up with, you're not gonna see the difference, and it's not even gonna be there. So remember, good practice is to have all the users as at user level with no sudo permission. Then you have a root account just for emergency that you lock out, you never use, and one maintenance account with sudo permissions, so the sysadmin can always log in and try to fix the disaster that the other users have made. Okay, so yeah.
If people want a break or just want to keep going, my section will probably be about the same length.
It's up to you guys.
I'm going to take silence as no break. Oh, or any questions, fine.
If you want to do the shadow and history, and then we take all the files,
Cool.
all the questions on Linux in general.
All right. Okay, yeah, so this shadow and history slide's a little bit outdated. I'm actually going to talk about something slightly different. Lots of you might have used Windows before, and you might have heard of the registry. That's a kind of weird, like, part of your computer that isn't actually stored in any particular file. Unlike that, Linux stores absolutely everything in a file. So like Stefano was talking about earlier with sudoers, we can actually see who is a sudoer just by who's in the file. So if we go to this directory on our computer, we can see a lot of like important system files. One of these, if we grep for it, is sudoers, and if we were to try to cat this out, we'll see that. I do. We can see that we don't actually have permission to do so. So let's chuck sudo on the end. Oh, can you type in my password? It's a total hacker password as well. Lots of numbers. All right, cool. So in this case, it looks like actually all the users on Stefano's computer are sudo, and that's because there's only one, and it's him. But this is an example of a file that if you're in CDX, you might want to check now and again, because it's one of the files that are commonly exploited by hackers. They'll sneak their name in there, and then they'll be able to do whatever they want with your computer. So be aware of it. I think that's all I wanted to talk about on the whole Linux side. Yeah, does anyone have any questions about Linux?
Anything.
We're by no means experts, but if you want to ask. Yeah, sure. No questions?
No? We're not lecturers, so just don't be intimidated.
Cool. You can ask afterwards if you want.
Right.
All right. Is everyone happy to talk about networking for a while? Ooh, networks. All right. Let's skip this. So, who here has heard of an IP address? Nice. Who here thinks they actually know what an IP address is? Not very many hands. A couple of hands over there. You guys are probably overqualified for this workshop. We'll talk about it anyway. All right. So, all computers on a network communicate with protocols. What is a protocol? It's just a standard that all the computers and all the companies have agreed on that allow them to talk to one another and understand one another. It's kind of like a language. And you can see here that there's quite a lot of protocols, and they all have different jobs. So today we're going to talk about IP, TCP, maybe SSH, and HTTP. And if you want to know more about them, just Google them. So imagine this. You're in Glasgow and you want to send a letter to your friend in Australia. This is the address you want to send it to. You probably take your letter to a post office, right? Well, what happens? The letter doesn't just go straight there. You don't really know where Sunny Street in Australia is. You just know its address. You don't know its physical location in the world, and neither does the post office in Glasgow. So it sends the letter to other post offices around the world, which it thinks has a better idea of where Sunny Street might be. So in this case, Glasgow thinks, I don't know, maybe I'll send it to London, maybe they'll know. London doesn't know either, so they send it to the post office in Australia, presumably there's more than one of them, although I've never been. And finally, the post office in Australia knows where Sunny Street is, and it hits the house itself. Well, the exact same thing happens in a computer network. So instead of 20 Sunny Street, we have an IP address, and it's literally just a label that's given to the computer that allows people to send messages to it. So we can see here your computer that looks like it's from the 90s. You should really do something about that. Sending a message between different routers until it finally hits Google servers. This might be like the router in your house. This might be halfway between here in California, and this might be in San Francisco, sunny San Francisco. So now imagine that instead of giving the address 10 Sunny Street, you just had to tell them the physical location in the world of this house. You had to go to your post office and tell them this number. Would anyone be able to do that? I'm just going to take the answer as no. There's no point in me asking that question. Right? So yeah, this is what happens. What coordinates do you want to send this letter to? What? I have no fucking idea. So this is known as a MAC address. Has anyone ever heard of a MAC address? Does anyone know what it is? I gave a basic explanation. Yes, you know. Some people over here I think are probably a lot more qualified in networks than I am, so I'm embarrassed myself right now. Yeah, so like we said before, the Glasgow post office has no idea where 10 Sunny Street in Australia is. So it had to send the message along to people who it thinks are more likely to know until someone finally knows the actual physical address. So maybe in Australia, the only post office in the world that knows this coordinate is the post office directly connected to it. So that's kind of the whole idea behind a MAC address. You have a physical coordinate of your computer that never changes. So like a house, once it's built, its physical coordinates are never going to change. Or they should never change, although, as we know, there are lots of hackers in the world and they found smart ways to change them. And only people directly connected to that device know its MAC address. So you don't know the coordinate of the house, only the post office directly connected to it does. Does anyone have any questions so far? I might actually, do you know what? There's a way to like get like a question link. I really want this because I feel like everyone doesn't know what I'm talking about, but they're not too scared to message me. Start. Yeah, there we go. Yes. Thanks, Clip. All right. Yeah. Can everyone see that link? It says VABKHD. If you have any questions, go to it and type, and I'll find it. So you can just sit in silence, right? All right. Okay. I'll check the questions in a second. So, like I said, only the router directly connected to Google actually knows its MAC address. And this is a summary about what we just talked about. So, all right. I've got a question for you guys actually. What about in the case of Wi-Fi networks? Does anyone know which devices know which other device's MAC addresses? Does anyone want to have a guess? Oh, where did it go? This sucks. Stefano, you fucking troll. This isn't a good question. Aha. What is computer? Nice. Lol. Alright, great questions. Alright, let's talk a little bit about the MAC address and the Wi-Fi scenario. So, with computers with MAC addresses and a Wi-Fi network, all of the computers share the same airspace and they all communicate radio signals across one another's paths. So actually, a lot of them know one another's MAC addresses, And you're able to see all of the MAC addresses that your computer knows if you use this command, which I think Stefano actually used earlier. Yeah. Come type your passwords. Do you need to? ARPA also works sometimes when I'm here.
What? Oh.
Thank you. Yep. Cool. So this is just a list of all the computers that whose IP addresses and MAC addresses your computer knows. Cool. And here's another question for you. Does anyone know how their laptop or their computer gets an IP address when it connects to a network? Oh, I hear voices, but they're all. Yep, exactly. So there's a thing called DHCP, and on your home router, you're going to have a little DHCP server running, and when it detects a new device connecting to it, it assigns it an IP address. So your laptop's MAC address will never change, but when you connect it to a new network, it's going to assign it an IP address. And so you can feel free to change the IP address if you know the command for it. All right. Spanner, your laptop isn't actually charging. All right. Has anyone seen this diagram before? Yes, a few people. This is the standard model of a computer network. So this is really just kind of an abstraction. None of them are really segmented so nicely into different layers. But this is what we've talked about so far. So the data link layer, you have a MAC address, and it allows you to communicate just between two computers that are directly connected. And an IP address allows you to communicate between computers across a massive network, across the globe. Has anyone heard of TCP? Quite a few people. TCP does a couple of things. So it works on the transport layer, like we can see here. And the first thing it does, which is great, and we need it to do this, is that it guarantees that your message actually gets there. So your letter is never going to get lost in the way. And the way it does this is just that when Australia receives your letter, it replies with a thanks, got it. They'd have to shout pretty loud, but I guess that's how it happens. And the next thing it does is it allows multiple programs on the same computer to communicate. So you can imagine having an IP address and people are sending you messages all the time. How does your computer know which programs to forward these messages onto? Well, if you imagine a letter, what you might do is write the name of the person in the house that you want to receive the letter. So we'd say 210 Sunny Street, and we want myself to receive it as opposed to Jesse, Sally, and Steve. The exact same thing happens again in a computer network. So we can see here that we write the IP address and then something that we call a port number. And different services have different standard port numbers. So a web server is port 80, an email server might be port 465. That's the port number from Minecraft. Some of you might have typed that in the past and not realized what you were actually typing. And maybe a hacker might use port 1337 because they're trying to seem cool. Leet. All right. Let me check the questions. Oh my God, man. I'm glad everyone backed me up. Thanks, guys.
Joe, there are a couple of good questions towards the top. Yep.
Oh, yeah. Oh, cool. Are they at the top?
Yeah.
Oh, no, they're here. Where can I find the presentation? Nice. Available online. What is the airspeed velocity of an unladen swallow? Depends how fast you throw it. Why do you need a MAC address and an IP address? Thank you, fantastic question. So, that might have been answered in this slide, but your MAC address is only available to devices that are directly communicating. So when I plug a cable into this laptop and a cable into a router, they both know one another's MAC addresses. It's like literally people's physical location. An IP address is like just a label that your computer is given, and that's so that yeah, it's so that your computer can be taken somewhere else and plugged in, and your MAC address doesn't need to be like, you don't need to tell everyone on the internet that your MAC address is now in a new place. Do we understand that? I'm going to look that up because that's a good question. Also the police.
Yeah, so what happened was, because it's very, very easy to obtain a new IP address, and the police was struggling to finding like ID numbers to connect that to your computer, what they did was creating MAC addresses, and MAC addresses are burned in the ROM of your physical devices, like for example your Wi-Fi cards. Even your phone has a MAC address that's unique to your phone. The first three hexadecimal digits of a MAC address are basically the producer of your antenna of your phone. There is a table of that. So if the police knows that a certain MAC address connected to a crime, they know the device. That's your device's fingerprint. Of course, there are ways of changing it, but we're not going to teach you the MAC changer.
Yeah. So when you have a MAC address, you're supposed to keep the same one, and that's a way of identifying you. Yeah. The reason is just that there are different levels. There are different like levels of abstraction in a network. So these are only used to communicate device to device, and these are used to communicate across an entire network. Hopefully that makes sense. Feel free to come and ask more questions about it afterwards. I'll tell you all of my knowledge, what little I have, and you can Google it as well. Arch Lance Master Race, nice. Oh, what's the difference between a MAC address and an IP address? Does anyone still want to know the answer to that? Is anyone still unclear on it? No. I guess if I haven't explained it by now, I'm not very good at explaining it. Okay. I'll come back to this. Not hacks, sorry, no. That's a great question. So, can two people use the same IP address? Yes, as long as they're like on different networks. So, one thing we can actually do is, to see our IP address, we can type in this command here. So let me just do that again, called ifconfig, right? And that stands for like interface config. And you can use it to see all of your interfaces and the IP addresses that are assigned to them. So we can see here that this is Stefano's wireless card and his laptop, his Wi-Fi card. It has this MAC address and it has this IP address. And someone else in the world might have this IP address because right now we're inside Edgerome, so we're inside a network where people from outside can't see in. And someone else might be in a similar situation. So when you sit at home on your laptop behind your Wi-Fi router, you might have like the IP address 192.168.0.3, and I might be sitting at home on my Wi-Fi router, and we might have the same IP address. And that's because we're hidden from the rest of the internet, so we're allowed to have the same one. If you want to know more about that, look up what a NAT is. So this, and you might find out. Can you have both an internal IP address and an IP address? Yeah, exactly. When you send data out of your network, it only gets labeled with your router's IP address. Yeah, so that's exactly what NAT is. Oh my god, I'm not sure I want to. I might do this tonight though. And a virtual machine. Yeah. Alright. Check out check out this GIF, by the way. It's probably older than most of the people in this room. What else we got? Yeah. Yeah. Has everyone heard of a firewall? Surely we have. It's like 101. A firewall is just a device or a program. You can run it on your computer, or maybe like big enterprises have a physical firewall that they plug into their network, and it routes all of your packets through it, and any packets that it doesn't like the look of, it just kind of like gets rid of, like it burns in a pit, and it's used basically to protect you from any attacks that might come from outside. So your little router at home has a firewall built in, and it would stop any nasty attacker sending like weird information to your computer that might result in it doing bad things. So no one's able to actually hack you because a firewall is sitting between them and you, and it blocks any traffic that looks suspicious. One reason it might look suspicious, by the way, is if it's on a port that isn't recognized. So 80 is common for web servers, 25565 is common for Minecraft. But any other weird ports, your firewall might block it.
Sorry, going back to like when you said that two machines can have the same IP address.
Yeah.
If two machines did have the same IP address and they requested something from a server, how would it know if the MAC address is only known to things that are directly connected to it? How would it know which device to send the information to? Does it send it to all of them and then use the MAC address, or?
That's a good question. So the server that receives that message is only going to know like it's only going to recognize one of the IP addresses, one of the computers that has that IP address. So say both you and me choose the same IP address for our computer, and we both send a request to a server somewhere. That server is only going to know about one of us. So if you connected to the network first, then it might know about you. If I connected first, it might know about me. So the network isn't really designed to have multiple people with the same IP address. So if you both have one, one of the people who has the duplicate might just not be able to send and receive stuff properly. But that's the question. If anyone else knows a lot more about networks than me and wants to correct me in anything, feel free. It might be a bit complex. All right. So, does anyone know what happens when you type www.google.com into your browser? Does anyone know the first step? Ooh, I might as well not do. So, when you type Google into your browser doesn't know where to send the request to, because it doesn't know the IP address of that server. So it uses a protocol called DNS, which stands for Domain Name Service. And what your computer will do is send a request for the IP address of that server to some DNS server that it knows about. So 8.8.8.8 is owned by Google. And if you ask it for, say, Facebook's IP address, it already knows it and it will send it back to you. So we can check this out by using the ns lookup command, which is name service lookup. So if any of you own a website, it might actually be quite interesting to look it up. If we type in ns lookup google.com, we can see that this is Google's IP address. So if you were to go to this, you should get Google, although they might actually block it because it's not a proper domain name. But let's try it. Yeah, let's try that. Yeah. So this is just a little tool that you can use to see what IP addresses correspond to what domain names. And if you've ever seen attacks where someone hijacks someone else's website, so say like a government website is hijacked by like lulzsec, and they've just forward it to their own web page. Quite often this is because they've hijacked the domain name for it. Alright. Maybe we should have like a 5-minute break. Does anyone have any questions? You can come up and ask. Whoa. That's good.
To go back 1 second to that question about two people having the same IP address. So theoretically, DHCP, what a DHCP does is like it tends not to give the two machines the same IP address. The way it works is like you can have two machines having the same IP address on two different networks. So think of a network as, for example, this room. This room is a network. So a DHCP address would be like, for example, a lecturer standing here and just going like number 1, 2, 3, 4, 5, up until like you finish all the numbers. So each and every one of us in this room, which is like our network, are going to be having a different IP address. But let's just say that this room, which is our private network, is like your room, your like your house. When it's trying to connecting to the bigger internet, it just connects this room with like it just gives this room an IP address, and then it connects to the rest of the internet. So when you're in your flat connected to your router, you're getting an IP address called an internal IP address, which is literally your IP address in your home area, and then your router gets an IP address for the rest of the internet. One way of showing it is if you type the command that Joe gave you guys before, which is ifconfig, you see that my IP address in this case is 172.30.183.92. This is the IP address, this is the name of my computer inside of EdgeRoam, because we're all connected to EdgeRoam. But if I go to like a website, for example, whatismyipa.com, which is going to tell me my public IP address, you're going to see that it's different. So see, like, is 130, 209, and something else. The two addresses are different. This is because I am getting an IP address inside of EdgeRoam, and then EdgeRoam is getting another IP address for everyone connected to it. So what happens is, like, you connect to EdgeRoam, like the post office address that he was speaking about before. You connect to EdgeRoam with an IP address, then EdgeRoam asks the question to the internet. Then basically a server on the internet is going to reply back to EdgeRoam, and EdgeRoam is going to remember that it was you that asked the question and give back the packet to you. So yes, you can have the same IP address, but probably it's going to be in different networks. Does that clarify the thing a bit better, maybe?
Hopefully. Alright, we'll take a 5-minute break. When we get back, we're probably going to talk about how to copy files between different machines in a network, which is quite simple.
It's all hands-on, and if you have either a Linux machine or if you have a Mac machine, you can follow by because they're both Unix-based and most of these commands will work. I'm going to do an example on TCP sockets, and if you have Python, I'm going to write it in Python. So any machine with Python installed, you can follow along and write the code and see the code working. Okay? Cool. Top notch. Yes. So the Linux terminal, do you have a Linux machine? No. Right, so you can't access the terminal on Windows. So Windows has a terminal, which is the CMD, but is less powerful and does not have these commands. So to access the Linux terminal, you need a Linux box or a Mac OS X because they're both Unix-based. So there are like different families of operating systems. So Unix-based are Linux and Mac OS X. So they both share the same type of terminal, roughly. But Windows is like, let's say, just like a distant cousin. So they don't share the same terminal. So no, if you're running on a Windows machine, you can't run the same commands. there are probably like emulators and stuff for it, but
How do you say the TCP thing? What does it do again?
so TCP is a protocol, it's a transfer control protocol. So it's the protocol that is in charge of getting your packets and making sure that your packets goes where you want it to go and make sure that it's deliverable. One of the things, yeah, so for example, like we are speaking and a sentence is composed by like words and every word is like a packet of information. You need to receive the packets in the correct order in order to decode the whole message. So when you're like asking, for example, I need like the HTML code for this website because I want to watch this website. The website is replying with packets. I'm going to do an example on a TCP. We're going to create a TCP server and a TCP client, so we're going to have them communicating to each other.
So just a way of sending.
Yes, exactly. So you have a package are pieces of information. It's like a letter. So they contain the address you send them from, the address you send them to, the content, and other like stuff.
They just arrange it.
Yeah, no, they're like small bits of information. We're gonna also like I'm gonna run Wireshark, and you can see some live packets.
Alright, you teach people how to DDoS tonight.
It's fun that you ask. Not tonight, but if you come along to the main event, there may or may not be a DDoS lab for you guys.
Oh, okay. The last question is, you know about like ping?
Ping, yes, exactly.
Explain.
So a ping is almost a protocol in itself.
Sorry?
Ping is like pokes on Facebook, widely annoying. So what ping does is literally just like send a random packet of data of ping type to, for example, google.com. And what it's doing is like, right, I'm sending a packet, which is that big of data, and then hopefully I'm going to get a response back. And I'm telling you how long does it take between my first packet being sent and Google saying, hello. Sorry?
Does it tell you like what the Boolean value for that actually works?
Yes, they do send you, it depends because it's a different protocol. So TCP has a certain syntax, UDP has another one. It's like different protocols, yes. I don't have that book now with me, but there is a book called, there's an incident response book. And at the end of it, it has like all the dissections of the different packets.
Nice.
Because like always like the first, I don't remember, like for example, the first 20 bytes of data are, I don't know, like the IP address I'm sending it from, then there's the port, then it's like specified. So if you're tracking traffic, you can do some cool stuff, like for example, capture the packets, clone it, modify a bit, and just send it, which is called man in the middle. So you're actually controlling the traffic of someone or spying on someone, which is pretty useful.
Can I speak after you?
Yeah, sure, absolutely. 100%, yeah, no problem. No problem.
So cool, man. I'm so happy. Because like I do percent I'm considering dropping it.
Right, okay.
And like this is just like you know like
The thing is, like in third year it ramps up, but it's harder to keep up with the pace if you haven't been introduced to these things slowly. The difference between second and third year is pretty high, and so that we're hoping that you can use this knowledge also for your own good in third year.
like all the presentations, are you gonna put them online or like?
We're gonna present. So we are recording the video live, and that's gonna be on the Facebook page. The slides are gonna be on Facebook. So all the material is gonna be on Facebook. And if you're coming to CDX, do come.
I would love to. Like I have some.
Damn it, maybe next year.
Definitely.
But if you have a question, just like send us a message or something. We're happy to reply anytime. We have another workshop tomorrow, which is going to be like more hackery event. So
People like some of them is like, oh, I already know this is boring. At the end, you might think this was basics of basics.
yeah, of course.
Other workshops are like way more in depth. So
Definitely.
We were talking, I had no idea whether anyone actually watched it.
You know that's like just because you're doing an event and like bunch of people upload it and it's like for the crowd and stuff. No,
Right.
no, it's really good times.
Did you understand like most of this?
Well, like I did this when I started like messing with it when I was 11.
All right, okay. Yeah.
But no, like it's so good. You know, it's really back into the time. Like, yeah. Thanks, guys.
No problem.
Is it like very like rude if I just leave the middle?
No. Leave whenever you want. Yeah.
What's your name by the way?
Stefano. Nice to meet you. Yes.
Yeah, we've been in character like
Yeah, no, we'll sure meet again. No worries. I'm gonna be around here.
Using those networks, I don't know what. So what would be the best way to get started using those?
Nice.
I
Nice.
reckon if you like just like use it all the time, that's how to really get like fast. Like, for all your projects in like first and second year, you can usually use Linux.
You're doing computer science.
Are you a computer scientist?
Okay.
Just very, very few approaches.
Yeah. Yeah, this is like it's to try to get everyone up to speed really fast, but if you know the first time, you're able to really just like keep up.
Will there all the information be available?
We'll put the slides on and we'll put a recording on as well.
Alright, cheers.
Okay. So welcome back, everyone. I want to, while we wait for other people to come in, there were a couple of good questions that have been asked. One of them was, what happened when my DHCP table is full? So IP addresses follow a specific pattern. So it's 4 numbers separated by dots, and the numbers go from 0 to 255. So when you have exhausted all numbers between 0.0.0.0 and 255.255.255.255, which is a lot of number, well, you have used up all the IP addresses, which is why we are switching between IP version 4 to IP version 6. So because we are running out of IP addresses on a global scale, then people higher up decided that we're going to invent a new standard. The new standard is 8 hexadecimal numbers that go from 0000 to FFFF. And if you do your math, that's a heck of a lot of more combinations, but not many of them, not many computers already accept IPv6. Another one was, what about static IP addresses? Which is a very good question. So what happens is, for example, Google will hopefully never change his own IP address because it has a static IP address. So the DNS tables all over the world, and Joe said correctly, like one, for example, is at 8.8.8.8. They know certain IP addresses to be linked with specific websites. So some of them will never change. You can get your own static IP address. There are ways of getting it. But normally what happens is with the majority of your phones, you're going to get a dynamic IP address. This is how a DHCP table is freed. So whenever your phone disconnects because you're going to uni, so you're no more connected to your home Wi-Fi, your IP address is freed and can get assigned to another device. So when you get back home, you might have a different IP address. This is a bit annoying if you're trying to have a Minecraft server because you need a static IP address. But yeah, these are all very nice questions. I love the B-movies one.
Who said Windows more than Linux? You'll learn.
I mean, I was a Windows guy up until 3rd year, and then I discovered the terminal, and my mind was blown away. Will we need to download Linux to be a part of CDX? If so, how? Right, I'm going to keep this question for the end. The quick answer is no. You don't need to download Linux to be able to take part of CDX at all. We don't discriminate on the basis of the operating system that you're going to use. But if you download, if you decide to keep having Windows, it might be good to download PuTTY. So a terminal emulator, so you can run Linux commands from a Windows machine. Because otherwise, PuTTY is to SSH, is an SSH client. So Cygwin is the terminal emulator. You might want to install both, so your life is a bit easier. Okay, so swiftly moving on to some of the demos. So how do we connect to another computer when we don't have physical access to it, which is exactly what you will have to do in CDX. Well, we use a protocol, like Joe said, which is the SSH. Right, so think about this way. when you were younger, you would just like pick up your phone and phone one of your friends. So you would just like get your phone out and write their phone number as your friend. Your friend would just respond, pick it up, and we would have a communication. Then we discovered computers, and we invented a protocol called Telnet. The Telnet protocol was a hybrid between what we actually use today and and me picking up a phone and phoning someone. So the Telnet protocol, all it was doing was, if I knew the IP address of of another person, so as if like the phone number of the other person, I can literally just write Telnet, the IP address of the other machine, and we would be communicating with each other. But Telnet does something which is really bad, and you'll notice that in my last demo. It sends all the packets in clear text, and that's very, very bad because it doesn't encrypt anything. And if I'm in the same network and I'm sniffing the traffic, I see you. I see everything you do. I see all your communications, all your passwords. I can see everything that is happening. It's like your very annoying little brother just hearing in your room where you're like speaking about either girlfriend or boyfriend. Is not good. SSH is mainly, it builds on top of Telnet, but what it does, it encrypts everything that has been sent. SSH stands for secure shell, so it's secure by default. If you're students at Glasgow University, you will learn in third year that you can SSH into your machines, which is great because you're going to have loads of stuff to do, and you can just like go home, chill on your sofa and do your assignments, which is 90% of your time. So, for example, if I want to connect to my machine, which is at the 7th floor of this building, I can just issue SSH. What is that? Well, first of all, I need to get on a VPN. I'll explain what a VPN is in a while, but just trust me on this one for now. Right. So if I do SSH, then my GUID, which is my username, at. So the first part is the username that I'm going to authenticate in the server with. The second part is the server. Of course, I don't remember the IP address by heart, but it's great because it's cebu.dcs.gla.ac.uk. So this is the server where all our machines are stored. So if I do it like this, it will be like, right, I want your password. I put on my password, and there I am. I'm logged into my machine, which is at the 7th floor of this building. So I am inside of the command prompt of that machine without having physical access, which is gold for CDX because this is exactly what you will have to do. In fact, if I issue who am I, it will tell you you're 2132699S, which is me in Glasgow University speech. I can exit now, and the connection between me and Cebu is getting closed. SSH is such a powerful command because this is only one way you can connect to a machine. So this is the old-fashioned way of, I know a username, I know a password, I know the IP address of the machine, I'm providing these three information. But sometimes giving people around passwords is not as good or as safe. So we invented something called private and public keys. I'm not going to go into like encryption, hardcore encryption and how that works. Also, I'm not showing you my private keys because I actually use them. But a private key is a very, very long password of random letters and numbers that get generated. And if you exchange your private and public key with a certain server, you can authenticate in said server without providing the password, which is great if you're in a team project. You just need to give everyone a copy of the key. They just like use the key and connect to it. So using what we've learned tonight, let me just like make it a bit smaller. Right, I have so see this key, which is called stefano.pem. That's a key file. That's one of the keys I've saved in my computer. And if I do vim of project.sh, this is a script that my friend Andrew and myself made when we're annoyed of typing all the time a long SSH key to get into our production servers. So this is just command for get this private key, get this either private key. This is the username, this is the server, this is the second username, and this is the second server. Because what this script does, it authenticates myself into the computers upstairs. Then once it's there, it's connecting to another server that can only be accessed within that network. And I have all my third-year projects in that server. So please don't hack it. So if you see the command at the end, it's using the SSH command, but is a bit of a more complicated version of what I've just showed. But we can dissect the command. So what I'm doing is SSH -i. -i specifies that I don't want to connect via SSH using a username and a password, but I want to connect via SSH, specifying just a public key file. And I'm passing the lab key, and then I'm authenticating as lab user and lab IP. Because the lab key is default, level 3 lab key is default.pem, and I have it on the server. Let me just quickly quit here. Default.pem, where are you? Default.pem is here. I can run this command and show you what is going to happen. So SSH-i default.pem, and then again, I just need to specify the username and the server. And I'm connected. It didn't even ask for a password. So I achieved the same thing. I am connected to my lab machine up the stairs. But this time, it didn't ask me for a username or for a password. So for example, if I want Joe to contribute to my project, I can just give him my private key. He's going to contribute to my project. Once that's done, because I trust no one, I can just remove that key from the trusted keys and make a new one. And he doesn't know my password, and he doesn't have access to that machine anymore. So SSH is really important. For CDX, all you're really going to need to know is how to do SSH and then authenticate with the -i option. Other things that you can do is port hopping, but except is port hopping, but you can get away with it. Port hopping is what it's going to do is going to map a port on the server to a port on your machine. Right. Now, let's just remember what a port is. A port is literally like a door that we leave opened, and then we have a listener on it. So a listener is like a person that stands at the door and is waiting for someone to contact. And when someone arrives with a message, aka a packet, knows what to do and does a certain operation and gives a message back. That's a port on a computer. There are loads of ports on a computer. Some of them are specific to certain services. As Joe said, port 80 and port 8080 are normally the web ports, so the one that you access a website on. Port 21 is FTP, if I'm not wrong. Port 22 is SSH. So these are all the ports that your computer has opened and has listeners, which are programs that are just waiting for someone to connect and know what to do in that case. If you have a web server running on a certain machine, and that machine is closed to the internet, so you cannot connect to the port 80 on publicly, what you can do is port hopping. So what you're doing is literally saying, all the traffic that I'm saying on my local port 80, tunnel it through SSH, and forward it on port 80 or 8080 on the server. The way to do this is using the -L option. So the -L option just literally says, tell me what port do you want to open on your own machine, the host, which is localhost always, column, the port that you want to map on the other machine. So for example, if I want to access port 8080 on a server and map it on port 80 on my computer, so whenever I type localhost column 80 on my computer, I can see what's happening on the other side. What I write is SSH-i, the private, the PEM file, the whole string to connect, -L 80 column localhost column 8080, which is literally what I'm doing here. So if I try and access localhost 80 on my machine, nothing will happen. because I have nothing running on my machine on port 80. But if I use this script, which is doing exactly what I said, it's just like filled up with sudo dot slash is basically telling the Linux command prompt to execute a command. If you want to execute a bash file or a command, you do dot slash, and in this case it's called project.sh. It's telling my local password, and here I'm in my production server. So it's already done everything under the covers. And if I bring back my browser and I go on localhost, I don't remember if it was 80. Right, I'm in GitHub now. Well, this is the GitLab of my group. This is like where I'm storing all my third-year project files. But what I wanted to demonstrate is before connecting via SSH on localhost 80 was happening nothing. Now I'm mapping my port 80 on my computer to another port on another server somewhere else, and I can easily connect and do everything from a web interface instead of having to type in commands. So this is SSH. Any question on SSH or anything that you want me to show again, show better, anything? Do I have to go back to the anonymous questions, or should I not? Right, hello world. You just did. No, you don't. Right. So is everything clear on IP addresses? Yes.
I was wondering, if you have like two computers and they connect to each other via an SSH connection,
Yes.
is that like conflicting between or?
No, because it is exactly what happens. So, well, as any connections, you need to have a listener and another computer that connects. So, for example, that server was sitting idling, and then I just like called him. It was like we were in different rooms, and I just like pick up my phones. I dial your number, your phone rings, and you pick up. It's the same thing. So it doesn't really matter who. SSH works like not both parties have to make the connections. Just one party calls for the connection to be made. Once the connection is made, data can pass through. It's like literally creating a link. Is the virtual version of connecting a cable. So once the cable is connected, data can pass through. It doesn't really matter if the connection is made by my machine or the server, as long as it's made. So yes, there will be no conflict. Right. So Joe's going to walk you through SCP.
Yeah.
And
I think we should make this our last thing, and then we can just open for questions. Like, you can come up to the front and ask, or you can like ask anyone else who is an expert. Is anyone else a networking expert here that's willing to answer questions afterwards? Got a hand here. All right, I'm going to ask. All right, so yeah, this is the last part of the workshop. So you've seen how you can SSH into other machines. So you can essentially have like your command prompt here, but it's on a remote server somewhere else. But what happens when you want to? Oh yeah, sorry. What happens if you want to transfer files, which is something you might want to do during CDX? Well, for that, instead of SSH, we have something called SCP, which is secure copy. So where SSH made a shell that you could use to execute commands, this time SCP can be used to copy files between machines. So let's see that. So I'm going to log into the university computers again with my information this time. What the hell? Stefano? Are you connected to?
VPN connected.
Oh my god, can we disconnect?
It's connected.
Let's disconnect.
Oh.
Right, cool.
No, you need to be connected.
No,
Otherwise
I
that
don't.
doesn't work.
Oh yeah, oh my god.
Yeah.
Yeah, that's it. Alright, cool. So this here is just the URL for the university computers, like the computer science servers. So I'm just going to enter my password here. Alright, so now I'm logged in, and if I do who am I, we can see that I am my Glasgow Uni ID. So what do we have here? A bunch of crap. And we have this file here called helloworld.txt, right? So, say we wanted to copy this helloworld.txt file onto our desktop. Let me first actually just put some information in it, so. Alright. That should be enough. So let's cat that out just to make sure. Does anyone know why this isn't working? I did a control. Alright, let's use a different file then. Alright, so we can see this kind of like placeholder index file here on my account on the university computers. So let's exit out of this. So now we're back in Stefano's laptop. And if we do similar to the SSH commands, so we have all the same stuff here, and we change this to CP, then we can specify a file that we want to copy. So in this case, it's going to be index.html. And I'm going to copy it onto Stefano's desktop, if that's okay. Index.html. And you could actually choose a different name for the file here if you wanted to. So this is what the command looks like. And hopefully it'll work. So let's hit enter and type my password. And we can see that index.html was copied over. So this is what it looked like on the server. And if we go like this is the index file here. So let's actually open this, see what's in it. This is from ages ago, so okay. Small networks coursework. Yeah, so we can see this file that we just transferred from the university network onto this computer locally. Yep. Does anyone have any questions about what we just did? I think in that case.
People are asking about the TCP stuff, so maybe.
Alright, cool.
Last thing.
Cool.
Right. So, all of you, if you're studying computing science here at Glasgow, know Python. Even like from first year. And oddly enough, Python is a language that is widely used in security because it's fast for scripting and doing stuff. There is a book called Black Hat Python, which is absolutely amazing and tells you how to use Python to do web hackery, opening networks with different stuff, how to decode IP layers and stuff like that. It's very, very interesting. And I'm going to take an extract of that one to demonstrate what a TCP communication looks like. So we're going to write a small TCP server and a small TCP client in Python. It's very small. You can follow up if you want to. And then we're going to have them communicating against each other. So you see that they actually can send different messages. So if I cd into PFP, and if I do gedit TCP server, and okay, so this is what a TCP server in Python looks like. It's very, very small. You can't even read it. How does one it's not getting bigger. Do you know how to make it bigger? Oh, preferences? No. It's tab width and stuff like that. Does anyone know how to make it bigger? Sorry? Yeah, it's gedit. Alright. Woo. Let's make it like grammar-like. Whoa. Bit less. Right, okay. Can anyone read it? Okay, so what are we doing is we're importing two things. We're importing socket, which is a library that takes care of TCP communication, UDP communication, this kind of like networking stuff. Threading is to create multi-threads and have your computer working on more than one thing at a time. But we're not going to go in depth into threading because it's very complicated. So first of all, what we do is we specify a variable called bind_IP, and we set it to 0.0.0.0, which is standard for your own computer, localhost. That is the IP address that we're going to start. Bind ports, you can literally type any number, really. I just choose 9999 because it's normally like not used for anything else, so it's secure. Now, next thing what we're going to do is we create a server, which is of type socket.socket. Now, this first part, socket.af init, is standard for saying, right, we're doing some network communication stuff. The second part, socket.stream, specifies the type of communication, which in this case is TCP. If you wanted to have a UDP server, you would write exactly the same thing, but instead of socket_stream, it would be socket_dgram. It's just two different protocols. Basically what we're doing here is we just created an empty server and we just told him, right, what you're going to do right now is do some communication using the TCP protocol. At this point, we need to specify, we need to tell him, right, you are going to listen in this IP on this port. So what we're going to do is bind what we just created, so server.bind our IP address that we specified up top, which is 0.0.0.0, to a specific port, which is 99999. You could literally write these two numbers in here, but it's easier to have them as variables up top so you can change them easily. And then I'm just telling him to listen, and that 5 is just the interval. At this point, I just print out something because it's always nice to have stuff printing out so you know when it crashes. So it's just going to tell you, okay, I'm listening on the specific IP on this port. So we know that when we read that line, our server is ready and listening. This is the slightly more complicated stuff, but don't get scared about it. All it's doing is using multi-threading to have various workers listening on that port. So we've opened the door, we're expecting someone to communicate, but because it's in computers are really fast and they send loads of communication, we can't only have one thread, so one person just standing at the door, because otherwise the communication would be too slow. So what we're doing is just like creating more than one thread to just like be queuing there, so as soon as the first message arrives, one works on that one, and we can still like have a communication on that port. So what we're doing is creating a function that as input has just the client socket, and what it's doing is printing out whatever the client is telling us. And this 1024 is just saying the length in bytes that we're going to receive, because we're sending a very small message for now. Normally you would have to do some fancy calculations, but right now what we really care about doing is just receiving a message and printing it out as easy as it is. And what we want to do though is, because as Joe said, we need also to let know the client that, hey, we received the message, thank you very much for your postcard. So we are also going to send back a message containing ACK with which in computers means acknowledge. So, okay, all good, received this, copied. And what we're going to do, just for show purposes, is we're also going to print out the client who's going to connect to us. So we're going to print out their IP address and port. At this point, we can close the communication. That replies to your question. So what we're doing here is one call the other person. We finish the communication, then we can close the communication, and that channel is over, is no more there. If we want to communicate again, we need to open up the channel again. This is the while loop that basically is just going to keep this whole thing going up until we kill it. What we're doing is we're just creating variables. We're just accepting the connections and getting whatever the server.accept function gives us into a variable called client and a variable called address. We're printing out that we accepted a connection from a certain person. And this part is the multi-threading that I would just say, just copy what it is. Don't be really scared or fussed about what that does. But all it's doing is just having workers, so threads, working on it for now. So this is the first part. Once you have this, you have a TCP server in Python. It's 37 lines, so as you can see, it's nothing too complicated because we've talked about abstractions and stuff. It can be as small as 37 lines of Python, including comments and spaces. So it's really not that big of a file. Now I'm showing you the TCP client. It's even smaller. So the TCP client, all it does is calling the TCP server and just sending a message. So what we do, we import socket, which again is the library that takes care of the communication layer. And we are specifying the target host and the target port. So the phone number and the channel to use. So in this case is 0000 because again it's localhost, and 999 because we already know that. At this point we create a socket object. As we created a socket object for the server, we create a socket object for the client as well. Exact same line. So we just create a client and we just tell him we're going to do some networking, so sockets AF init, and we need to use the same protocol. So because our server is a TCP server, we need to have a TCP client, so it's going to be socket sockstream. At this point, what we do, we literally make the call. So we do client.connect on the target host, on the target port, and we send hello world. But what we could send is we could literally send anything that we really want, which is a message, as long as it is less than 1024, because that's the limit that we put on our server. And then we receive the response of the client and we print out the response. So when all these print functions, they don't have to be there, but they're there so we can easily demonstrate that the communication has happened between the two things. So what I'm going to do, I'm going to open up a terminal. Still going to keep this up in case people are still copying. I'm going to make it a bit bigger. And what I'm going to do is cd in PFP and Python TCP server.py. So as we said, I'm just executing the first file that we created, and what it's doing is just listening on the thing. It's just telling us, right, okay, I'm all set, I'm just ready to receive any communications. And if I open another terminal, and at this point, make it bigger. At this point, what I'm going to write is, well, cd pfp, of course, and then Python TCP client. As soon as I send this, what it's going to do is connect and send our message. So it's almost instantaneous. So we received a connection from us. We received a hello world. Oh, I didn't save it. That's why. Always save your files. So now that it's saved, we're going to keep the server opened, but we're going to execute this again. So this time it received a different message, which is B movie is great. So what we effectively done is we created a connection between a server and a client. We sent a message. Message was received. We printed out the message, and the client got notified that the message was received. So this is as easy as it is to work with sockets. As long as you understand what you're doing, you can find good guides online, and Python, so even if you're a first year, is great to get started with. Thank you very much for not throwing tomatoes at us because it's been pretty long and intense. Hope you guys liked it. And any questions that you have, just fire it to us, and we're more than happy to show you anything. If anyone is interested in seeing what a real life packet looks like, you can stop here for a second. I can show you Wireshark. Otherwise, you're free to go. Thank you very much for coming around. Note before you leave is this was a very introductory workshop. We have more workshops lined up. Tomorrow we have an amazing workshop on penetration testing and security, and I highly suggest you come around. Monday we're going to have another one on sys administration. And if you're interested in taking part in CDX, is loads of fun. The last batch of tickets goes live tomorrow. Yeah, tomorrow at 7. Oh, Monday at 7. So be there. Thanks. Right, we'll post everything online if you're interested. If you have any questions, just write them and we're gonna reply. Good. Amazing.